So whenever I actually talk to ChatGPT always says like that happened because of the TLN, the theta. So as theta as T increases, the theta also increases, or the denominator, something like that. Because of the sigma, the n terms, the root of sigma. So as you increase the sigma, um, then you're also increasing the denominator, so something like that. So because of those conversations, it made me decide, what, let me actually build that dashboard. I wanted to actually see it for myself, calculate it for myself, to see all these relationships, because it's always being referenced as I talk to ChatGPT. So I actually want to know that too, and by doing that, it became clear to me, what, you know, each relationships, the generalities, what can be said about the formula, that the denominator is, what does the sigma values, how does sigma values affect the denominator, for example. So it as you increase the sigma values, then the denominator is also increased, and then, but more than that, I also saw how sigma 0.5 has a more clean looking denominator, especially at the multiple of 10. So like 100,000, it's, the returned value is like 10, 100, 1000. So I think that also contributes to the symmetry. And in fact, I also asked ChatGPT if there's any other sigma values that behave like that or outputs like that, and no, it's actually just sigma 0.5. There might be, but there are other conditions, but it's sigma 0.5 that is, can perfectly output like clean denominators. um so what else? And also it is sigma 0.5 that has a modulus output that is linear looking, perfect linearly decreasing as you increase the t value. As we increase the t value, the modulus keeps getting smaller and smaller, but you do have to, or I do have to, make sure that I have the correct n term. So the fourth collection, we do see that the most appropriate n term is actually 220,000 for that range, not 100,000. So I could do two things. I could change the range to maybe closer to 100,000 if I want to keep 100,000. And you might think, why would I do that? Because it does take a while, a bit, to calculate. So I have another dashboard, the first dashboard, and you do notice the difference when you change the n terms to over 100,000. So it starts to lag. So I could change it to 220, or I could just change the range of to just about 100,000, not farther from 100,000, because that table 4 actually ventured to like almost 500. So maybe keep it at 100, 200. So that's that's something I can do instead of changing the n terms. Yeah, so I like other sigma, even though it's very nearby, it's only like 0.005 increment, 15 to the left, 15 to the right. You can see that the modulus outputs were not linear. It's messy. It seems periodic, like increasing like at other, and it has different shape and forms. other T collections, it was like increasing and then falling, immediately falling and increasing again. And others, it's just, it's just chaotic. So and all of this comes from the fact that the sine and cosine, when you plug in the function, even though the theta and the t are both linear in relationships, once you plug into that cosine and sine, that causes the unpredictability, since cosine and sine are kind of like a circle. It's an oscillation. So so that also affects the modulus, but we do see that the modulus output has a linear, almost perfect linearly decreasing when at sigma. So it's only the sigma that actually produces that, and it does help that sigma, the denominator, when multiples of 10, does also inputs a clean denominator. So